file you imported are all in the same place, it should work. If not, I think that I can look at what you're doing after class.
Okay.
Right? Anything else? Yes?
Mine keeps giving me an error using triangulation,
Error using triangulation.
and then it's referencing like an error within search to solve
Yeah. So it's not completely robust, right? This function, right? We grabbed it off the website, so most wrote it. It's not a perfect function. And I've run into that, and by massaging my X and Y, make sure you go through the mesh grid. Right, that I said, I don't know if you're doing that, but set up an X, the Y, do the mesh grid, compute Z, and usually it works, but if it has singularities, your function, or something, right? I'm not convinced it's going to work if you have,
it.
right? So, I don't know, try massaging the function a little bit, add one, see if it gets rid of any similarities. That's kind of my best advice there, right? Because it's not a good error message, it's like, I wonder what's wrong, right? Not that helpful. Any other questions? I'm asking questions about the homework due today. Yes?
So we have to use that, you can't use that, sir.
Fserv is a function. It takes a function in and plots using the function, but you don't have X and Y defined and you don't have your Z defined, it's not going to work.
Okay.
So, no, that for this to work, it has to have a bunch of points in X, Y, Z space. Not a function. It has to be an array with just a bunch of X, Y, Z values. So, yeah. And for those of you who don't know what functions are yet, that's today's topic. So, yeah. Yes.
Whenever we do that coding that is down, and we're gonna put like SQL right or something.
Yes.
How do we know that it turned out properly, that it'll print with the assigned dimensions properly?
How do you know your print property? Good question. If you got an STL file, there are other programs that you can view it if you want to, right? It's a standard format used in CAD, so I'm pretty sure that,
Windows is built in one now, so click on an STL file.
No. Cool, I didn't know that. I thought we had to grab a CAD file. Okay, or a CAD program to do it. Okay. See, I learn something every semester, yeah. You had your hand up, were you just going to answer? Okay. Thank you. Yep. So hopefully that will allow you to view it, right? The STL does not have dimensions in it, right? That's the format, does not have dimensions. It's a unitless thing, right? And then when I need it to print it, I will print it to a size. Any other questions? Okay, so sounding good. So let me just tell me what the next homework assignment is, and then I can tell you how we go about doing it. Okay? And that way you have the motivation to pay attention, right? Not sleep for class. Okay, so what we're going to do is we're going to work with functions. So we're going to find 3 ways of forming a function, and so problems 1, 2, and 3 requiring you to set up a function using all 3 methods, right? The same method would work for all 3 functions I have here, but I want you to do it 3 ways. Yeah, just because. And then, and so the functions are sine squared x times cosine squared x, and then because I'm super, innovative and everything, the next function is sine cubed x times cosine cubed x, right? And then the one is sine to the 4th x times cosine to the 4th x. Yeah, okay, so we'll get a couple of functions here. I asked you to plot them just so that we can see what they are, and I want you to set them up as functions, right? And so we'll name them functions 1, 2, and 3. Okay, then we compute 3 integrals. So that's the other half of what we're learning today. One half is how to set up a function. The other half is how to do an integral using MATLAB. And so if you look, this is the first function we did, this is the second function we did, and this is the third function we did. So you integrate over the three functions. And the integrate command requires a function, which is why we go through the pain and suffering, it's not painful, of setting up a function. So then we'll learn how to integrate in one dimension. You'll be like, yeah, I can integrate in one dimension. Then I give you a fourth function, and this is xy times x squared minus y squared over x squared plus y squared, and it looks like a funny function, but we actually saw that plot in the last class. Okay, so we'll just use it, why not, right? So we'll plot it, and that's a page break, so down here we evaluate an integral over two dimensions, right? A double integral. And so it has a range that we integrate over x and the range that we integrate over y. So we'll learn how to do that one. And finally, one more thing to do so that you do one more function, okay? It's just another double integral. And so when you turn things in, you're going to have to give me your script file, right? I want you to do all your work in a script file in this class, right? So you write up the script file, has all your commands, and it does it. So that .NET file. Publish it, right? So publish and give it your file name, and then it runs through things and makes plots and puts it all into nice PDF so that I can see it and say that yes, it indeed works, right? And then step 3, in the .m function files that you create, you have to create at least one. One of the three methods of making functions is to create a file that contains your function. So, because I require that, you have to do it at least once, and you have a couple of integrals which I leave it up to you how you want to create your function. So if you use more than one function file, include them all, right? But I know you're including at least one, because the first way to do it, right, you're going to have to create a file. Okay, so that's going to be the homework. I'll upload it after class. It's not actually uploaded yet. And so this is, exciting stuff. And we'll be able to do next week even more complicated integrals and use it in a more meaningful way than this, right? I like to tie everything into electrical engineering somehow. We'll do that next week, right? Before we did MOSFETs, right? Plotted the curve. But we'll take it step by step, right? It's a 1 credit hour course. I need to try not to give you too much in one homework assignment. So we'll do this, you learn a lot, you'll be yay, right? And all will be good. And so, here we are. So a function, if I typed sine of 0, right, it calls the function sine. I can set up the same thing, and here what I have is f1 of 0, and normally you just random things, right? If I came down here and I type a of 0, it'd say, unrecognized function or variable a, because it's not defined. So if I come up here and I have f1 of 0, normally you'd get an error message, but over here, I have already created a file named f1.m. So just like there was a strreq functions that you put into your directory, if it's sitting there, when it has an undefined function or name, it says, I wonder if there's a file with this name. It checked, it will find it, it'll say, yay, I got a function, and it won't execute that. Yes?
So if you wanted to create a variable called f1 in your function, you could do that, and it would use f1. It wouldn't use the script file that you wrote.
I don't know the answer to that, I'm sorry. I have to try it out or look it up. I do not know which. I'm pretty sure the variable will be the variable and it will not use f1 anymore. I'm like 99% sure, but there's 1% of me that says I'm not positive, right? Yeah. So his question was whether we had a variable f1, which is going to be used the variable or called the function. And I'm 99% sure it's the variable, but I make no promises. Okay, so we have a function here, and how do we know it's a function? Well, it's a .m file like any other script file, but it starts with the name or word, the keyword, there we go, the keyword function. So it is a function. You get an output, will be y, and this is hidden to this function, right? I can use y in another script or anything, and it is not affected, right? This is internal to this function, is y. f1, and then I have parentheses x. Well, x is a parameter coming in. Again, x has nothing to do with x anywhere else, like in your script file, right? It's only known within this file, within this function, does not show up in your workspace. Percent sign to have a comment, right? I got a couple of comments, right? And then I can put whatever code I want. This is a very simple one. Y is equal to sine x times cosine x. I can put if statements, I can put for statements, I can do whatever I want and do tons of calculations. But the only thing that comes back out of the function will be y. Okay? So if I go back, I have a few things. I'll just run this section and it runs and I get the answer is 0. Well, sine of 0 times cosine of 0 will be 0 because the sine is 0, the cosine is 1, but 0 times 1 is 0, so I get an answer of 0. And I got an answer of 0, and I said, yay, MATLAB can compute a sine and a cosine and multiply them together, right? No big surprise. Let's do something else, right? I'm going to give it f1 and I'm going to give it 0, 1, 2, and 3. And I get an answer that's a matrix. Why? Because I sent a matrix into f1. So f1 up here received a matrix, and I got sine of x. Well, sine will work on a matrix, cosine will work on a matrix, and I multiplied with the dot star so that I did element by element multiplication. So what happens if I take this dot out? Okay. I'll go send it. And I will try this one more time, and I got an error because when I tried to multiply sine, which is a matrix, times cosine, which is a matrix, one of them was not rotated, right? That's not a row times a column, or column times row. I could do it either way, but 2 rows, that's a problem. Okay, so that's no good. But I can put this star back in here, and then I do it, and it's very happy to do matrix arithmetic, right? So what you want your function to do, right? You get to decide, but you can have if statements, for loops, you can plot things, you can do tons of things inside a function. But a function returns something, right? So a script doesn't return anything, it's a bunch of statements. A function is a bunch of statements that return something. An easy way to create a function is if you go over to new, well, there's script up here, right? But there is function. So if I go to new function, it brings up a template. And what we see here is that inside brackets is output arg1, output arg2. So it is letting us know, right, this is system template. We could return more than one thing. My other example was to return y. Well, maybe I want to return a and b. And put it in brackets a comma b. And then I can define a, I can define b, and return from the function, it returns the matrix with both a and b in it. So I can get more than one thing out of a function. The function's right now untitled, right? I need to give it some name. Right? I could use untitled once, right? Not a second time, now I have a problem. Right? So I give it a name, hopefully something descriptive, because, you know, in my experience, when I start naming things A, B, C, D, E, F, 2 years later, I have no idea what the function did. Yeah. And you can have more than one input, right? It's like plot is a function, you give it x and y. Well, function can take more than one variable. And then at some point you have to define output argument 1, define output argument 2. Because that's what returns. And again, you can do whatever you want in here, but this is just an easy way of getting this. And what's really neat, let's say that I had F1, so I'll make this F2, right? For function 2, super clever name, right? Okay, so I was calling it F2. And if I go to save, it's hard to see, but file name already says F2 on it. And that is smart enough to say, hey, you're naming this function F2. It should have the same name in the file. All right, so hit save, done. Now this is not a super clever program, that's the template. What does it do? It took 2 inputs, input R1, input R2, and made the outputs the same as the inputs. So now if I came down here, and I said F2, and let's give it 1 and 3, right? Now my input arguments are 1 and 3. I should get back. Oh, I only see 1 by default. Okay, so here's an interesting thing. If you want to get more than one thing back from MATLAB, you put it into brackets and put it 2 parameters. Give it 2 variables. We'll drag it into here, and this time I got A is 1 and B is 3. So that's how I would get more than one thing out. Most times we get one thing out, we're happy with one thing out. But if you have a function that returns more than one thing, you gotta know this trick, right? So that's method 1 for making a function. Make a file, give it the name of the function, and things back. Can't remember the syntax? Don't worry about it. Go to new function. It will create it for you. And it is pretty descriptive and pretty easy to follow. Yes?
When you're calling the function, you use F1 because that's the name of the script file.
Yes, yeah.
It doesn't matter, you don't name it on the function line at all.
Well, it is named here. So here's F1, and it says y is equal to F1. So I don't know. I've never played around with it to see what happens if you change its name. Okay. Let's just give it a try. Why not? Right? Let me make sure it's saved. Now I have F1.m, and it says F3. So I'm curious. Actually, let's make it F10 because I have played around with things. And so if I say F1, 5, no errors. Doesn't seem to matter what it says up here, right? So I think that F1 is just for us, but MATLAB seems to ignore it. I wasn't quite sure what was going to happen there. But that's when it's in a separate file. Now I'm going to show you it's not in a separate file. So I got rid of F2 because now let me do a second example. I'm going to find F2 of 0, but it's not in a file. And so how do you know what's going to happen? Is anything going to happen? Let me run this section. And I got the answer 0. You're like, whoa, how did that happen, right? Well, F2 is defined, but it's defined very end of this file. So if I have a script file, I can define functions at the very end. MATLAB is very peculiar about this. If you define it in the middle somewhere that says, oh, what are you doing, right? If you program in C, you have to define your function before you use it, right? In MATLAB, if you define a function before you use it, you get an error. You're like, what? Right? But that's the way it goes. They will say, what are you doing? This function is supposed to be at the end of the file. And you say, okay, if you insist, I'll move it to the end of the file, you move it to the end of the file, then it works. Kind of bizarre, right? But it has to be at the end of the file. So F2 now is at the end of the file. It's the same format as that function when it was a .env file. It has the keyword function, where your output is y. The name of the function, now it wrote an address, right? Because it's not in a separate file, right? And inputs, in this case x. So y is equal to sine x times cosine x. I'm doing the same thing, right? But I'm doing it as separate methods. So this is method number 2. Method 1, create that .env file with the name of your function. Method 2, create your function at the end of a script file. If you create a function, right? Maybe you're working for NASA, right? And you're creating this big old rocket and it needs to go to space. And your job is to figure out this part of things, and you write a function that's super important, right? And someone else has to use it. You don't want your function inside a script file that's your script file. You want a function that you can hand to someone else. You create it as a .env file because many people are going to use it. If, on the other hand, you're creating a function that you don't need to hand off to anyone, or is part of this computation, but it's not a function that you expect other people to reuse, right? Stick it in your script file. Okay, there's a third way of making functions. Okay, so we have F1 was separate file, F2, right? Of course, it comments to myself, where's the function, right? At the end of the file. Okay. The third one, here's a third way of making a function. This is called an anonymous function, which I don't know why it has its name, right? I'm sure there's a reason, right? I just never looked into it. But in MATLAB, it's called an anonymous function. So if you hear people say, oh, set up an anonymous function, doesn't mean that it doesn't have a name, right? But that's what it is. So here I'll have F3, right? That's my third function, is equal to, and here's what, instead of a normal statement would be sine x times cosine x, to make it a function, I add this ampersand, parentheses x, parentheses. And now MATLAB knows, oh, wait a second, I need a function to solve this. I'm not going to compute this today or right now, or maybe later today. I'm not going to compute it right now. I'm going to compute it later when F3 is called. And so then I can count F3 and give it value 0, it'll plug it in there and compute it. Okay? And that way you can have the function defined right before you use it. You don't have to scroll to the end of the file to find it. But this one, it's kind of hard to do if statements, for loops, and other stuff, right? If you have a function that, is 100 lines of code, I'd probably put it in its own file. If you got a function like this, sine x times cosine x, it's small, it's short, you don't need to put it in another file, then someone's looking through the code and they're like, oh, I got this function, I wonder what it does. You have to open another file to find out what's going on. I think this is much easier to understand. So for simple functions, I love this, right? For complex functions that are 100 lines long, right, I'll put it into another file.
That's kind of like what we did for the STL write and serve
Yeah.
to solid, yeah.
It is, right? The STL writes a different file, right?
Mhm.
With a bunch of lines and lines and lines of code.
Mhm.
Yep. Yeah, all those, and some notes wrote it for us,
Mhm.
put it up on the MATLAB website, we're like, thank you, right?
Right.
And used it, yeah. Okay, so those are 3 ways of making functions, and doing this is when you have to do all 3 ways on your homework assignments. And so we'll go through 1, 2, 3, there we are. So the other part of the homework is to do an integration. Okay? So if I want to integrate something, so then we know what we're integrating, okay? I'm going to use F1 and F2 and plot. Make it turn into Y1, Y2, the Y values, and plot it from 0 to 2 pi, okay? So if I run the section, what do you mean there's an error? That's fine. Oh, I know what went wrong. Okay, never mind. Okay, I had this moment of panic, right? I actually set it up with an error so that because it's a common error that happens all the time, and so I want you to see it in how we solve it, right? So I had this moment of panic when, oh my God, what did I do? I had this lecture all set up and it failed, right? It was supposed to. Okay. Okay, so what do we have? Oh, it's not even getting the first part. Okay, let me create its own section, run this section. Here's our plot. F1 and F2 are both sine x times cosine x, so they're identical. There's 2 proposed, you can't see them, okay? But we've got 2 functions here, F1 and F2, and it plots out, right? Sine x times cosine x gives you this plot. Sound good? Oops. Okay, there we go. Okay, now what I want to do is integrate. So the way you integrate things is use the command integral. Sounds simple. Give it your function, right? F1 or F2, and then the minimum value and the maximum value of the function. So I want to integrate from 0 to 2 pi. There we go. Now here is the problem, right? This doesn't actually work. It tells me not enough input arguments. The most cryptic error message ever. Because it's not the input arguments that's the problem. Yeah. What it is MATLAB understands a function, but the variable will often point to a function. It's called a function handler. And so it actually wants not a function, but it wants a function handler, a variable that points to a function. You're like, what? Right? Okay. If I put an ampersand here, it points to the function F1, points to the function F2. Now they're function handlers, and that says, oh, that's what you're doing.
Oh, it's like having the and symbol in C.
It is.
Okay.
Yeah, it's like adding the ampersand in C. Yep. And then it says, oh, now I know what you're doing. So this time I run it, no errors, and I get an answer. But I did it twice, right? Once for F1 and once for F2. The functions are the same, I should get the same answer. And I got the same answer. Now let's look at our function for a second. 0's in the middle. Half the time it's positive, half the time it's negative. From 0 to 2 pi, the answer should be 0. It really should, right? I mean, it's sine times cosine, but if I had just a sine, from 0 to 2 pi, it should integrate up to 0. Right? So you imagine this is just a modified form here. We should get the answer 0. Did we get the answer 0 from MATLAB? And the answer is no, we did not. Look at that. Something times 10 to the minus 17. What MATLAB does on the integrate command is that it says, I need, do you remember Simpson's rule and the trapezoidal rules in calculus? And you're like, yeah. And so you add up all these rectangles or trapezoids to approximate an integral, and then you never use it again, right? MATLAB uses it. That's how it's trying to come up with a solution. So, it sends an array into F1. Right? What boundaries does it choose? I don't know. Right? It has an algorithm. Some computer programmers who really know how to integrate things super well, right? Spend a long time doing this. In fact, there used to be a different function for integrating things in MATLAB, and they've improved it, so now they call it integral. Okay, so there was other ways of doing it, right, which I'm not going to teach because this one's better. Okay, I'm teaching an old thing that's obsolete. So people who really know what they're doing have set this up, and they figured out how to, as fast as possible, iterate through how many points you need. Make sure that if there are any singularities, that you find them, identify them, and get an answer. Despite singularities, despite positive and negative numbers, despite things that might be processed through multiple times, right? You don't just look at the start and end and hope for the best, right? And so these algorithms exist, they try it, and it gets close to zero. If I want more accurate, I can give the integral command some options about how what its tolerances are. Okay? But I don't get zero because that's not what it does. It's numerically integrating things, and so this is a fact of life. When you work with computers, it's not right? You don't have things to infinite precision. No number returns for infinite precision. You can't integrate delta x going to 0. Okay, it takes an infinite amount of time to integrate that over any distance, right? So that's the limitation of numerical algorithms. It always has some tolerance. So MATLAB has some tolerances. If you're very interested, you can look it up, right? I'm not going to spend the time doing it. You do a help on integral, right? You look through the documentation. There's some relative tolerances, absolute tolerances. You can look at all that stuff and see how to set it. If you're like, oh, 10 to the minus 17, not close enough to 0. Okay, you mean better than 17, right? Digits out, right? You can do it, right? You can make it better if you want. But this is the default accuracy for MATLAB. So let me just repeat this one more time. If I take this ampersand off and try to run it, I get an error that says not enough input arguments. And so if you get this scripted thing when you're doing your homework and you can't get integrals to solve, and you're like, what's going on, right? It's these ampersands. Yeah. Sorry, that accent. It's the accent. Right? Drives me crazy. What can I do? Okay, I did not do F3 on this one because F3 is different. Okay, so where is F3? Let me run this section. Here's something really neat, right? Here's F3. It's an at, right, with the x. So it's saying it's a function, but look at my workspace over here. F3 says at x sine x times cosine x. If I come down here, now just type F3 with no parentheses, it will tell me it is a function handle. It's already a function handle. So if you set up a function this way, it operates different and when I did F1 and F2. Those were actual functions. This is a function handle. Okay, I know. I'm sorry. I wish it were more straightforward, right? Yeah. But it's a function handle, which means when I do an integrate, here's my integral, right? I give it F3. This time it's going to work without saying at F3. I'll prove it. And there we are. There's our function, same function. Got an answer times 10 to the minus 17, and it worked. Look at that. No at sign. So we do have to know this difference, right? And if you say, man, why did they do that? I don't have an answer for you, right? But that's what we're stuck with, okay? So, works very nice. Okay, I have a couple more examples. Double integrals. Last class we had this function cosine x times y. And it oscillated 1,000,000 times, and so this time I'm going to go from 0 to 2. I forget, it was like 0 to 10 last time, and I'm like, too crazy. We'll go 0 to 2. Okay, so let's space from 0 to 2, put 100 points in here, do a mesh grid. F4, that's now a function that gets me it. And then if I want to know values of z so that I can do mesh x, y, and z, okay, I have to actually call z is equal to F4. Because F4 is a function, it's not an array with a bunch of data points. So to use mesh, I need x, right, a bunch of points in x, y, a bunch of points in y, and z, a bunch of points in z. That's what mesh requires. So I need to set this up so that z will now be an F4, but that's my fourth function, right, of x, y, and it'll compute it. Previously, we just said z is equal to cosine x times y. This time I set up a function, and then said z is a function of F4 x and y. We'll plot it, we'll see it, and so let me show you real quick what the plot looks like. I can rotate this, I think it's easier to see, kind of like here. Sure, okay. So, here we are, right? At 0, 0, which is on the left side here, I can't reach high enough, okay? At 0, 0 is, because it's a cosine, right, it's what? Cosine 0 times sine 0 squared. So, at my origin, I did at number 1 with y'all here. By the time I come up here, it's down, and then it starts to curl up again, and then it's scaled by pi or anything, right? So, it has a complex function here. And I want to know what the integral of this is. You're like, oh, right? A little bit more complicated. Yeah, so let's see what we get. How do I integrate it? I use the command integral 2. Why the number 2? 2 dimensions. Guess what? There's an integral 3. 3 dimensions, right? I love when things actually make sense. Okay, integral, 1 dimension, integral 2, 2 dimensions, integral 3, 3 dimensions. So what do we have? We have F4. I defined it with that at. Oh, that's the other thing I did, right? My function now is a function of 2 things, x and y. Right? My other example was 1 dimension just at x. This one's at x comma y. So we get both x and y. And I can bring the function with both of them. When MATLAB calls this function, it's a function handle already. I don't need the at sign here. I give it the minimum on the x, the maximum on the x, minimum on y, maximum on y. Or think of it as minimum on first variable, max of first variable. Because it doesn't know what x and y is, right? Yeah.
If we were integrating y first and then x, with those at for F4 at xy, would it be at yx? If we're integrating Y first?
Yes, yes.
Okay,
Yep, yeah, you'd want to change it around, right? It's
Okay.
gonna integrate that first variable on the left and then the next
Okay.
variable. Yes,
Okay.
yeah, so you could create it at Y comma X and
Okay.
change the order of integration. So
Okay.
it should not matter here, okay, this is not a contour integration where there's things that matter.
right, yeah,
But there are cases where that matters.
okay,
Yep, yes,
If you only, that would work. Never mind.
got it, okay, yes.
So does calling a function still work the same as calling a function like in every other instance other than?
I want to, most times it does, right? Every so often I get into trouble like the integrate command, or integral command, right? Then I get into this trouble where, oh, I wanted a function handler, right? And I'm like, what's going on, right? But oftentimes, I guess if you pass it into a function, it often wants a function handler, but it don't, if you're just using it, either way is fine. And so, I guess that's the best way to describe it. But I'd always check the documentation, see what that particular function that you're trying to use wants. Okay. Yeah. I use the help command quite a lot, just to make sure that I'm passing the right things, right? If I do a lot of MATLAB and using this function all the time, I know it, right? If it's a new function, I'm always looking it up. And there's so many functions, I still run into new functions, right? Yeah. MATLAB does everything. It's wonderful and bad, right? Wonderful because you can find a function to do it. Bad because you gotta search and find the function that does it, right? But overall, it's good. Okay, so if we do this integration, I get that answer 1.7582. Well, my plot was all positive values, right? The minimum z, oh, it's not all positive values, never mind. But most of it's at 1, and less of it's near negative 1. So overall, the integral comes out to be a positive number. And we'll get an answer, okay? That's not 0. See, I did so many examples where we get 0, but that was just to show you that 0 is not actually 0, right? You don't actually get 0, that's why I did that. That way when you run into that, you don't panic. So why didn't I get 0? Yeah. Problem with numerical routines. Okay, so we get 1.7582. Okay. The only other thing I had in this file is that, yes, I defined F2 at the very end. Right? I couldn't put it in any of the sections. I couldn't, then I would get an error. Had to go at the end. You can define more than one function, okay, at the end. That's all fine. But they have to come at the end of the file.
So it wasn't messed up by it being its own section and only running a section at a time.
It wasn't, yeah, isn't that bizarre, right?
Yeah.
Let me do, yeah, great question. So I
If
cleared
it at
everything.
all and tried to reference F3 outside of where F3 was stated, it would be.
It would have
assigned.
failed.
It would have failed.
It would have failed, yeah. So here's the question, right? If everything's clear, does it know about F2? Well, here, let's say this section uses F2, but it's in a different section, right? Look at this. Function F2 is defined in its own section, and yet, I will successfully, let me show you this, get F2 to work. Ta-da, it worked. No error
Because it's
messages.
just that definition
So-
of a function
so-
exists outside of the.
Yeah. Yeah, so that function is defined for every section. Now, what does not work, right? Yeah, this section right here. Why? I'm going to use F3. It's going to fail. Undefined function F3, right? It didn't work. Why? Because I have not defined F3 as an anonymous function. So I need to come up, where's it defined? Up here, and define F3. After I run this, right? Run this section, now you can see F3 in the bar right here. It is now a variable, right, function handler pointing to this function. Now I would be able to run this other stuff that used F3 because it's defined in my workspace. But if I did a clear all, I would lose it. Yeah. Yes. I will post this on Blackboard, yes. After class, I will post this on Blackboard and I will post the homework assignment. Yep. Yeah, any other questions? Then let's call it a day, right? 3 minutes early, yay! Yeah.